Hello students, how are you all? I hope you are doing well at home. Today we are going to discuss about a certain kind of substances which are termed as base. Previously, as we have learned the different characteristics of acid, like we have learned the physical properties, chemical properties. Today, unlike the acids, bases have a different set of physical properties that we are going to learn. So first of all, the first property of base is that bases are actually bitter in taste. Suppose if I talk about a particular baking soda that is present in your home, in your kitchen, okay, they will taste bitter. Okay, moreover there are more substances like soap, detergents that are used for cleaning and washing our body and clothes. They all contain bases. Okay, so bases are bitter taste, soapy to touch. When we touch bases, they are a little slippery. Okay, basic solutions conduct electricity. When bases are dissolved in water, they dissociate into ions. We are going to see what ions they dissociate into. Okay, that ions help in the conduction of electricity. Next, it turns red litmus blue in color. It turns red litmus blue in color. We have studied about different indicators. Hope you have gone through the video. Okay, now there are certain bases that are soluble in water. Okay, and there are more some bases that are insoluble in water. So we give a term to the water soluble bases. The term is alkali. So the bases that are water soluble are called alkali. Now there is a question that we come across when we study about bases, that all alkalis are bases but all bases are not alkalis. Actually, this particular point can be explained clearly. If we think that this particular whole substance is a base, this particular whole substance is a base, all the substances that are base are in this circle, and now if we catch that there is a certain part of bases that are water soluble, so they just make a part of the whole bases. So we say that all alkalis belong to bases but all bases does not belong to alkali. Okay, so we should explain this part very clearly when we are asked in the question. Now let us see what are the all kind of bases having in common. So if we talk about the common thing in all bases, the common in all bases, let us talk about some of the bases. Okay, like your NaOH is a base. Okay, now when it dissociates in water, it breaks down into Na plus OH minus. Okay, so this is a kind of base. When it is dissociated in water, it dissociates into Na plus and OH minus. Let us see more bases like NH4OH is also a base. It dissociates in water. Accordingly. NH4 plus ammonium ion and OH minus. Okay, we can see many more bases, CaOH2. Such bases also dissociates into Ca2 plus OH minus. Okay, now over here we will see that all bases, they are producing the OH minus ions. This is the common thing in all bases. So all bases have one thing in common, is that they produces the OH minus ions or the hydroxide ions. So we are writing it here. They produce OH minus ions in water. Okay, I am writing it in short. When dissociated in water, bases, they produce OH minus ions. Clear? Now, this, when we are talking about water, we actually talk about bases that are called alkalis. So in this chapter, we will be dealing about many bases that are actually water soluble bases. Clear? So now we will be talking about what are strong bases and what are weak bases. Okay. Now strong bases are actually the bases that completely dissociates, that completely ionizes in water. Okay, the bases that completely ionize in water, let me take a strong base, say NaOH. When it dissociates in water, it dissociates into Na plus and OH minus ions. All the NaOH molecules, they break completely, giving Na plus ions and OH minus ions. So hence there is a greater number of OH minus ions. Therefore we can write produce large number of OH minus ions. Okay. Apart from these strong bases, there are some bases which when dissociated in water, they do not completely ionize. Okay, so let us talk about those bases like NH4OH is a weak base. Okay, when it dissociates in water, okay, it dissociates into NH4 plus OH minus. This reverse arrow just signifies that these two particular ions, they quietly want to remain as a molecule form and hence reduces the amount of OH minus ions present in the solution of water. So we can say weak bases are actually partially ionized in water. Okay, so weak bases are partially ionized, and due to this partial ionization, what happens? There is a less amount of OH minus ions produced. There is a less amount of OH minus ions produced. Okay, so let us recapitulate how far we have completed. So bases are substances that have a bitter taste, that is soapy when touched, conducts electricity, and they turns red litmus paper blue. Okay, now the bases are some water soluble, some are not soluble in water. So the bases that are water soluble are termed as alkali. In this chapter, the bases that we will be dealing with are mostly soluble in water. So all the bases we will be using in this chapter are actually alkalis. Okay, now alkalis are just a part of a whole entity of bases. So we say that all the alkalis are bases, but all bases are not alkalis, as we know that the bases that are not soluble in water cannot be termed as alkali. Okay, now what are all the bases having in common? The common thing in all bases is that they produce OH minus ions in water. When a base is dissociated in water, they produce OH minus ions. Okay, now when we will be talking about a strong base and a weak base, what we will see that a strong base, when it dissociates in water, it completely gets ionized. It completely gets ionized, and hence there is a large amount of OH ions produced. Moreover, when we will talk about weak bases, they are partially ionized. I mean to say that the ions, they try to stay in a molecular state and reduces the amount of OH minus ions present in the solution of base, and hence they are partially ionized. Okay, so far we know all the physical properties of bases. Okay, now let us go forward to some chemical properties of base. In the first chemical property, we are going to see a reaction of a metal with a base. So let us write the base equation where a metal reacts with a base to give a salt and hydrogen gas. So, similar to acids, metal react with bases to give a salt and hydrogen gas. Let us see one example like zinc. When it reacts with NaOH, it gives Na2ZnO2. This is sodium zincate with the release of hydrogen gas. As we have read earlier that hydrogen gas can be identified by the pop sound. So what is the experimental setup that we prepare? We take a particular test tube. In which we fit a 2-hole cork. In the first hole, we put a thistle funnel which help to pour the base into the test tube containing some solid particles of zinc. So what happens due to the reaction of this particular base that comes through the thistle funnel into the particular test tube, it releases a gas. When this gas is collected in soap water, when this gas is collected in a beaker containing soap water, we have done it before in case of acid. When this gas that is released by the reaction of zinc and base NaOH, there is a gas that is released that is delivered through this delivery tube into the soap water. The soap water forms soap bubbles. When a candle is brought near it, we observe a pop sound. This pop sound is because of hydrogen. So in this first chemical reaction of bases, we will keep in mind the base reaction that the metal, any kind of metal, when reacts with a base, they give us salt and hydrogen gas. Now let us move over to the next reaction. We have read in case of acid, I hope you remember, the neutralization. Okay, neutralization reaction. In the neutralization reaction, we will see that an acid reacts with a base and they neutralizes individual's acidity and basicity and gives salt and water. We will see the next reaction. Acid, when reacts with base, they give salt and water. Let us talk about the acid H2SO4. When reacts with NaOH, it gives Na2SO4 plus H2O. It gives H2O. Okay. So in this reaction, we will see that the acidity and basicity of the acid and base respectively is neutralized and a salt and water is obtained. So this particular reaction is termed as neutralization reaction. Okay, this particular reaction is called neutralization reaction. We can see some more examples. Let us take HCl when it reacts with your potassium hydroxide. It leads to the formation of KCl, a salt, and H2O. Okay, so we can see that this acidity and basicity is neutralized with the formation of a salt. So this reaction is called neutralization reaction. One more reaction that we are going to discuss is when there is a reaction of non-metallic oxide with a base, when a non-metallic oxide reacts with a base, we see the formation of salt and water. We see the formation of salt and water, similar to the neutralization reaction. Let us talk about a non-metallic oxide, say carbon dioxide. We have gone through this reaction again and again. So this is one of the most important reactions. We know that lime water has a particular formula, CaOH, the test of carbon dioxide, where it turns lime water milky. So in this reaction, the non-metallic oxide, that is carbon dioxide, it reacts with a base to form calcium carbonate, and water. This is white in color. This particular reaction we have dealt the second time in this chapter. This particular reaction will also come when we will talk about whitewashing the walls. Okay, so what we know about that question, let us discuss. Whitewashing the walls with a solution of lime water does not turn bright at an instant. It takes time. Why? Because lime water has a particular formula, calcium hydroxide. Clear? Now, it takes a little bit time when it needs to react with the atmospheric carbon dioxide, where we are doing your whitewashing, and later on it reacts with the carbon dioxide molecule and transforms into calcium carbonate. So this particular reaction is a reaction of a base with a non-metallic oxide, where we see that the formation of a salt and water. Non-metallic oxides are usually acidic in nature, and hence they show the same behavior as in case of the neutralization reaction. Let us repeat the chemical properties. In the first chemical property, we have seen that a metal reacts with a base to give a salt and hydrogen gas. We know hydrogen gas will be identified by a pop sound when burnt. Okay, we know that we will collect hydrogen gas over soap water so that it form bubbles, and those bubbles will be brought near a candle. It will burst with a pop sound. Okay, next is the acid-base reaction. We have already read when we were reading the chemical characteristics of acid. Acid plus base gives salt and water. And finally, the non-metallic oxides, which are acidic in nature, they react with the base to give salt and water. So this was the physical and chemical properties of base. We have to know about the strength of acid and base with the help of the pH scale. Okay, so the next video we are coming up tomorrow again, okay, with the pH scale, and how we will understand whether a acid is stronger and weaker or a base is stronger and weaker. Okay, thank you. Please subscribe and like the